Hello guys, today I think it's a really good starting point to do some short revision for our first two videos, which is 1A, 1B, and 1C. And I collect four final year exam to help you guys to do the revision, so you can pause the video for each of the question and give it a try. Then I go through them in details. Okay, now let's look at the first one. So the first one is tells us it's a linear function, okay? Then give us domain, sorry, didn't give us domain, just ask us to find the domain and give us a relationship, which is 5 minus x, and the range is -4 to 5, okay? So let's draw the graph first, x and y. When my x equals 0, it's 5, 0, and when my y is my x is 0 is 0 and 5, so I directly draw the line over here. Okay, now make sure this one is range, so it's y value. Okay, so when my y is -4, which is over here, y equals -4, I need to find my corresponding x value, which be here. Later we're gonna find it. And now my y is 5, which is over here. And I need to find my x, which is empty circle, okay? Because it's small brackets. So I plug y equal -4 into the equation. It's 5 minus x. My x is 9, so which means over here. So my x value gonna be from starting point over here, empty circle, to this dot. Okay, so it should be 0, 9, like this. Okay, so the final answer should be A. Okay, the tricky part is normally we mixed with domain and range, but in here they tells us the range, which is y values. Okay, and they ask us to find the x values. Okay, so which is domain. Okay, so it should be 0 to 9. And again, this question is from 2016 exam 2. Okay, and 92% of students get this one at that time, correct? So I think only 80% people missed the chance because they mixed with range and domain. Okay, let's keep going. The next one, and again, you can pause over here, and I will go through it now. Okay, so for this one, they use the really good language. It's plain language. They just tell us the maximum domain instead of the implied domain. So, which means reduce the difficulty of this question. And again, the maximum domain of the function is R except 1. So this one we covered in 1A, and we call it one set difference. Okay. So technically speaking, x can be any number belong to R, but x cannot equal 1. Okay, this is a translation. So it means for look at which function the domain cannot include 1. So look at the first one. Okay, we have x squared minus 5 over 1 minus 1. So the basic rule is denominator cannot equals 1. So x cannot equal 1. This is one seems everything fits. So it's actually is a correct one, but we just go through all of them to just emphasize the maximum domain for this case. Okay, let's look at the second one. Second one is x plus 4 divided by x minus 5. So again, denominator cannot be 0, so x minus 5 cannot be 0, so x cannot be 5. So in here, the domain should be right like R, but exclude 5. Okay, cannot take 5. Okay, let's keep going. So for C, and the only denominator is this guy, but x squared plus 1 can never be 0. It's always greater than 1, right? So for this one, the x can be any real numbers, okay? Any real numbers over here. And for next one, over here, the denominator is x plus 1. So x plus 1 cannot be 0. So x cannot be -1. So it's R. And we don't want -1, okay? And finally, for this one, it's under the square root, so it's x minus 1 greater than or equal to 0, so its x should be greater than 1, which means it should be right like, oops, sorry, my bad, it should be 1 to infinity, okay? Let's move on to the next one, and this one is 88% of people got that correct at that time, okay, 2018. Let's move on to next one. Okay, this one is actually test us about chapter 1a. It's just like plug in, okay? So the F2 is 5, F3 is 4, G2 is 5, G3 is 2, G4 is 1. They give us so many redundant things. Let's just do one at a time, okay? Let's focus on this is what we want. F, G3, okay? So F, let's look at G3. Okay, G3 is 2. So which means I plug 2 over here. And again, I want to know what is F2. We already simplify. So F2 is, look at this guy. It's over here. So we just write 5 over here. So done. The answer is just like E. So for this question, redundant, redundant, another redundant one. Okay, we don't need to worry about too much of this. And this one is completely solved by our previous covered topics, okay, which is in 1A, okay? But sadly, this question, a quarter of students got this wrong. I think they accidentally missed this one and with later topic, which is like the composite function, okay? But that one, I'm gonna cover it in more detail, okay? Let's look at the final question. Just clean the board. Let's look at the final one, which is question 3. First, I want to say for this question, only at that year, okay, only 48%. So less than 50% of students get this one correct. Let's look at why it is the case, okay? The first one, again, they gave us a domain, okay, which is over here. So 0 less than or equal to x, and x is less than b. This is our domain. And our function is 1 over x. And we give the name is rectangular hyperbola, okay? We covered in year 11 math method. And we draw the graph over here. So my y equals x over 1. And another important one is a and b are both positive real, okay? So the general graph is like in quadrant 1 and quadrant 3, right? But our A, B are positive real, so we can directly get rid of the negative, and we can make the x over here, y over here. And we know it's A less than equal to x less than b, so we just randomly draw. Okay, make A over here, like make B over here, but just be careful. B should be empty circle, okay? Empty circle over here. And we just find the y value. So we go up, up, up over here. And we go up, up, up over here. Go horizontal over here. So it's like 1 over a, okay? And it's also the dot. Then for b, okay, we go over here, here, here. So it's empty circle. We go over here, horizontal again to get value over here. So it's 1 over b. And of course, we ask about the range, okay? So the range is y value. It's from the bottom, goes up over here. So from the graph, it's 1 over b, comma, and 1 over a. Square brackets is this one, okay? The tricky part is 1 over x, this graph is actually, it's decreasing, okay? By decreasing, what I mean is when my x1 is less than x2, but my fx1 is actually greater than fx2 under this case, okay? Positive real, because it's decreasing. So once this one, our range is not simply just plug in the number, we have to reverse it. So instead of 1 over A to 1 over B, we have to use 1 over B to 1 over A. And I think this graph can help you to understand these topics, okay? And understand what I'm saying. So this is all the question I want to cover. And for the next videos, I'm gonna keep going to the 1D, okay? So hope you guys find this one useful and see you guys next time. Bye-bye.